So this says to use absolute values to determine the distance between each pair of numbers on a number line. And where this can be really helpful is, like, if I asked you, how far apart are the numbers 5 and 3? You'd probably just tell me. If I gave you bigger numbers, and you had to use your calculator, like if I said, how far are the numbers 115 and 72? How far are they from each other? What would you do on your calculator? You would just subtract, right? Okay? It makes sense that if you want to find the distance between two things, 115 and 72, you would just subtract. Okay? Now, if I took, here's my number line, here's 115, here's 72. Obvious that it's going to be 115 minus 72. If I put absolute value bars around that, would that change that answer at all? First, you would do the 150 minus 70, you get an answer, which is, by the way, 43, right? And then the absolute values would just make it 43. Okay? But what the absolute value can do is sometimes you, like, when you subtract it, it made complete sense to take the big one and subtract the small one. But sometimes you might not get it right, which is the big one and which is the small one. Example A is a great example, because when I'm looking at them, your gut says 8.5 is bigger than 3.7. So you might think negative 8.5 is bigger than negative 3.7 and accidentally do this, negative 8.5 minus negative 3.7. Right? Technically, this is the small one, this is the big one. If I did it this way, can you see that the answer to this is going to be negative 4.8. But that's not the actual distance between them. The distance between them is 4.8. Whenever we're talking about distance, we want to talk about positives. So if we put absolute value bars around things, it doesn't matter which order you do it, you'll get the right answer. Because once I get to the end, I get 4.8. However, in part B, it's pretty obvious that the positive one is bigger than the smaller one. You wouldn't need the absolute values. But B is really good to practice our fraction stuff. So, if you had 4 2/3, and you wanted to subtract negative 5 3/5. Generally, in higher level pre-calculus, we don't like working with mixed fractions. We work a lot more with improper fractions. So instead of writing 4 2/3, we all remember how to change this to an improper fraction. 4 2/3 is equal to what over 3? 14. And what was your method for figuring that out? 4 times 3 is 12. And added the 2 on top to get the 14. Because the 4 is really 12 over 3. Like 4 and a mixed fraction is really 4 and the and is like a plus, it's 4 plus 2/3. And the 4, if you're adding fraction, you need a common denominator, which gives you 14 over 3. Now, when changing a mixed fraction to an improper fraction, most of us have learned that shortcut where you say, well, this 4 times 3 is 12. That's because that 4 is 12 over 3. And then you have to add the 2 to get 14 over 3. Minus a negative will be plus. Here, 5 times 5 is 25. This will be 28 over 5. Now, this one for sure, I had the bigger one minus the smaller one. You wouldn't need absolute values around it. So if you were doing this question and wanted to find this distance, you could just keep working here, because you're going to get a positive number in the end. If you were doing this and you ended up with a negative number in the end, you can just go back and add the absolute value bars along, and then you can be like, okay, change my number to positive, and my work's all good all the way through. So, like this first one, and I started this way. And I'm like, oh crap, my answer is negative. Should I erase everything and switch the order so it's positive? No, I just go back and say, I'm going to just add absolute value bars. And then I can make my answer positive in the end anyways, and it's perfectly fine. But in the second one, I don't even have to add the absolute value bars because it's already positive. But how do you add fractions?
Make the denominator the same.
And the denominators need to be the same. Can you see that the same denominator will have to be a 15, right? But that means for this first one, I'd have to multiply by 5 here, which means I multiply by 5 there, giving me 70. And here I'd have to multiply by 3, so I have to multiply by 3 there, giving me 84. And so I get 154 over 15. Now, did the answer key leave the answer as a fraction, a mixed fraction? Yeah. So, how many 15s in 154? There's 10 full of them. 10 times 15 would be 150, and there'd be 4 15s in the end. Okay? Now, I'm going to say that most of the time in upper level math we use improper fractions. That's not to say that it's the best way. I actually think if I was doing this in a better way, I would think of it like this. 4 2/3 minus the negative would be plus 5 3/5. If I thought of it this way, 4 plus 5 is 9. That's not hard math. If I need a common denominator for just those fractions, I would have plus 10 over 15, and this would be plus 9 over 15, which would give me 9 plus 19 over 15. I'm like, oh, 19 over 15, that has another 1. That's like 1 4/5. So if I put the 1 here, that would be 10 4/5. 4/15, sorry, which is a mixed fraction. I actually think that's better for mental math purposes. But you'll see a lot of upper level math just use improper fractions. Even if the numbers are not nice, you have a calculator at certain times, so it's not too bad. If I was doing this in mental math, I actually think that works out nice. A little bit easier to do. You don't like, 70 and 84. Those are big numbers. That's harder mental math when you have bigger numbers. This biggest number I had here was 19. Okay, so, we could sketch this on a number line as well, but we're going to skip that part. Because we sort of did one number line for an easier example. So the distance between the two numbers can be used with absolute values, but you don't need to if you know which is the bigger one and which is the smaller one. You can circle questions 5 and 8.